Joseph John Thompson was born December 18th, 1856, in Cheetham Hill, Manchester, United Kingdom. His father was a bookseller and publisher, and his mother came from a textile family. Originally, Thompson's father wanted him to be an engineer, but his family could not afford the apprenticeship, so Thompson enrolled in Owens College in 1870. And in 1876, Thompson entered Trinity College, Cambridge, as a minor scholar. Eventually, in 1884, Thompson was named the Cavendish Professor of Experimental Physics at Cambridge. His early interests in atomic structures are reflected in his essay entitled Treatise on the Motion of Vortex Rings, which won him the Adams Prize in 1884. J. Thompson received much recognition and many awards throughout his career. His most notable work includes the discovery of the subatomic particle, the electron. He reached this discovery with his experiments involving cathode ray tubes, which are sealed glass tubes that have most of the air removed from them. To test the properties of the particles, Thompson placed a positively and negatively charged electron plate around the cathode ray. During the experiment, the cathode ray deflected from the negatively charged electric plate and towards the positively charged plate, indicating that the particles contained a very small negative charge. Thomas knew that the particles were neutral, which led him to believe that there had also been a positive charge that could balance out the electrons. With this, Thompson came up with the plum pudding model of an atom in which negatively charged electrons are swimming within a soup of positive charge. This was later disproved by Ernest Rutherford.
Ernest Rutherford was born on August 30th, 1871 in Bridgewater, New Zealand. Rutherford's parents ran a successful farm near Nelson, where Ernest was born. One of 12 children, he liked the hard work and open-air farming, but was a good student and won a university scholarship. After college, he won another scholarship to study at Cambridge University in England, which marked a turning point in his life. There he met J. Thompson, and Thompson encouraged him to study recently discovered X-rays. This was the start of a long, productive, and influential career in atomic physics. Rutherford eventually coined the terms for some of the most basic principles in the field: alpha, beta, and gamma rays, the proton, neutron, half-life, and daughter atoms. Several of the century's major physicists studied under him, including Niels Bohr and James Chadwick. In 1911, Rutherford conducted an experiment alongside Hans Geiger and Ernest Martin. In the experiment, alpha particles were fired at a thin sheet of gold foil, and the deflection of the particles was measured once they crossed the gold foil. Based on Thompson's plum pudding model of atom, which was small mass of electrons and low concentrations of positive charge, the scientists expected that the alpha particles were to pass through the gold foil without any deflection. However, the results showed that most of the alpha particles passed through, but some of them were in fact deflected. Therefore, Rutherford was able to disprove the plum pudding theory and conclude that there had to be a localized region that contained the mass and all of the positive charge that is what we call the nucleus. With that being said, Rutherford crafted his own three-part theory, which states that most of the atom's mass and all of its positive charge are localized in the small core. Second, most of the atom's volume is empty space in which tiny negatively charged electrons are dispersed. And lastly, since an atom is electrically neutral, there are as many positively charged particles within the nucleus as there are negatively charged electrons outside of the nucleus. This led to the development of the nuclear model of atomic structure. While Rutherford's theory was accurate, it was in fact incomplete because he did not account for the mass of electrons within the atom.
Erwin Schrodinger was born in Vienna on August 12, 1887. He was the only son of Rudolf Schrodinger, who was married to his chemistry professor's daughter, Georgine Amelia Brenda Schrodinger, aka Georgie. Along with chemistry, Schrodinger was also intrigued by ancient grammar and loved German poetry. Although he was very intelligent, he hated memorizing data and learning solely from reading books. He much preferred learning kinesthetically. From 1909 to 1910, Schrodinger attended the University of Vienna. He mastered eigenvalue problems of physics. Eigenvalues are special sets of scalars associated with a linear system of equations and are applied in multiple ways, such as stability analysis, physics of rotating bodies, and small oscillations of vibrating systems. While studying, he was greatly influenced by Fritz Hasenauer, an Austrian physicist who helped in the creation of Einstein's famous equation E=mc². He then studied under Franz Exner, where he conducted practical work for the university students. Along with being a scholar, he was also active in the war efforts. From 1914 to 1918, he served as an artillery officer in World War I. In spite of this, his passion laid in chemistry and physics. He worked as a professor at Stuttgart, Breslau, and at the University of Zurich. When he was not teaching, he was studying thermodynamics, especially specific heat. His studies led to atomic spectra, studying the electromagnetic radiation absorbed and emitted by atoms. In 1926, he made a breakthrough discovery which led to his creation of the wave equation, which is used in order to find the allowed energy levels of quantum mechanical systems such as atoms. He considered the idea of precise orbits of atoms and decided that they more accurately are scattered about and occupy general spaces called orbitals, where electrons are most likely to be found. This model, called the electron cloud, is what is used today to describe the atom's configuration. These discoveries are what later earned him the Physics Nobel Prize of 1993. Schrodinger died January 4, 1961, in Vienna. Though he passed away over 50 years ago, his impact on the scientific community and how he reformed the idea of the atomic model still remains relevant today.